Hello, and welcome to AI behavior editing and debugging in Tom Clancy's The Division. My name is Jonas Gillberg. I've been at Massive Entertainment for 6 years, and I'm currently working as the technical lead AI programmer. While I hope that most of you saw Phil and Drew's talk on The Division yesterday, I'm still going to give you a quick introduction to what the game is. Tom Clancy's The Division is an online open-world third-person shooter RPG. After an outbreak of weaponized smallpox, the Division, an autonomous unit of tactical agents, is activated. As a Division agent, you must now restore order in a mid-crisis New York. So first, I'd like to give you an overview of this presentation. I'll first set you up with some more context on the archetypes and the architecture. Then I'll do a brief thing about the evolution of the toolset and our workflow, mostly because we intentionally set out to change the way we work, and we almost ended up going full circle and going back to the beginning. After that, since that also sets up how we work now, I'll give you a little introduction to the debugger that we have, the behavior trees that we use, how we edit them, and then I'll finish off with a real debugging example with an actual bug that we fixed for the game. So, yeah, those of you that were here yesterday might see that I stole this slide from Drew. Thank you. The important thing here is that for this game we have a lot of unique AI with their own unique behaviors. We have a lot of different systems that goes into that, and they need to handle a wide variety of both open world and scripted story missions. And for this, we're using a behavior tree architecture. Behavior trees are not new. If you want to read up on them, there's lots of good information out there. That will not be the focus of this talk. As an online game, our behaviors are running server-side, which gives us a slightly different set of constraints. But that's also for another talk. What we're going to focus on today is how we edit and work with them. One thing that I will mention first, though, is that we evaluate our trees from right to left. You do get used to it. There are reasons for it. I just don't think they're quite good enough anymore. Because and then the only question is like when to make that change. So if you find me at a conference at another time, please ask me about it, and we'll see what has happened. So, in the beginning, AI was done completely by programmers. They would handle all the state, all the links between them, what they did, what they contained, and everything. And designers might tweak some inputs, if they're lucky. But at the same time, in another part of the office, we had technical artists doing some mind-blowing things with visual node graphs that we had for art. They would do amazing things without programmer assistance. And so naturally, I mean, we wanted to empower our designers the same way they had been, and possibly free up some code time to do other stuff. So the first thing we did was to create just an editor view for behaviors that looks similar to the node graphs. So then just left it to the designers. So go do some things, and then whenever they're running into problems, they would ask us for just the small nuts and bolts to make it work. This system did not share anything really with the other visual scripting that we had. So whenever they asked for something, we had to re-implement that node. There were no reusable subgraphs. So we ended up with a lot of copy-paste. And in addition to that, whenever you wanted your changes to take effect, you had to restart the game. So this system became increasingly hard to manage, and, well, we needed to rewrite it. So at this time, we did it using we actually built it on top of the existing node graph system, surprise, And then since we had now all these common nodes, we had to do less redundant work. We also got access to the redundant subgraphs, what we call compounds, that will base a lot of our modular things on later. In addition to that, we also added the reloading, so you could actually stay in the editor and tweak things and get it running. Unfortunately, I think the rewrite probably came a bit late. We had already sort of used up all the trust from the designers. They decided behavior graphs are unreadable messes, best left to programmers. So we were pretty much back at square one. They would, we had some slightly more inputs now on the compound nodes, but programmers working inside the behavior trees, designers tweaked the inputs. We did eventually manage to work through it. I'll get to that later. But, well, now the programmers were the ones using the behavior editor, so we needed a debugger because we like some nice debugging things. So even though it was a bit of a pain to set up with the client server, your own workflow might get a bit more love. I'm not saying it goes for everyone, but it's sometimes a bit easier to just work for yourself. So this color scheme we are using, successful executions are green, failures are red, in progress, which means that nodes that updated, that tick this behavior update and will tick the next one are marked as in progress. Those that are inactive are gray, and the ones that have been interrupted this frame, which can happen, they're marked as orange. So that was just a quick introduction. So now let's get on to the actual debugging part. What you see here is a regression test map. We have one, this specific one has a lot of the archetypes that we use for the game, and it makes for a very easy place for bug repros, especially if you get one of our embedded testers to reproduce it here. It saves a lot of time. In this case, we're going to have a look at the area for the rider sniper. So before I start this, I'm just going to give you a bit of the layout here. As you can see, the game viewport doesn't take up the entire screen. I have a debug layout going, so the bottom of the screen is actually game debug history, where you can access historical debug information. You can scrub that and to see what was happening at the point in time. This will also pause and unpause the game as you're using it. And the top right is a debug dockable that contains a lot of debug options. And in the lower right is just the contextual properties of the currently selected debug entity. So I'm just going to spawn the rider sniper. He's going to spawn up in the top and the center of the screen. And after that, I'll go to the top right and enable some debug options. As you can see, we have quite a few of them, and the dockable used to be a lot more user-friendly when there were like 10, 15, and there's well over 300. So now I mostly use the console that has actual tab completion. In addition to that, we have a lot of different filtering functions. In this case, I'm only interested in information about the NPC, so I filter on NPC only. And then I enable a couple of extra debug commands, like debugging, behavior debugging, and so on. But when working with this, like enabling lots and lots of debug draw, it can get very cluttered. So we've separated the generation of debug event and display of them. And we can toggle this on and off, so you can run without them and then toggle them on later when you want to see them. You can also just save your settings so they're easily accessible next time. So just as a quick example for this, I'm going to show you the reaction he has when I throw a seeker mine and set that on him. Potentially saw that yesterday. So it's a dumb sniper that, well, he panics and dies. That's pretty much it. So let's just quickly go back and have a look at that. So as we're scrubbing back and forth, we can see what was happening at that point in time. And with him panicking, dying, we often want to correlate this with the actual behaviors, what the behaviors are doing at this time. So if we select him, that brings up the behavior debug information for him at that time that we're at in the timeline. Now, normally, this would show up on the second screen. They don't have that here, so it's just a small one, which is why I'll first go through the behavior tree before we continue, so you have a bit of an easier time finding your way. So this is the behavior tree system for the rider sniper. Again, things are evaluated right to left and then top to bottom. And as you can see, everything has been sort of color-coded and laid out with nice space. That was not done by a coder. It was a designer, and it was a really good idea. It makes things a lot easier for us. And as you can see, we have sort of different connection layers. And we also allow children to have multiple parents. This allows us to sort of slim down the tree instead of having it just explode. And one thing that is important to note here, that's I wouldn't say the details of what we've done is exactly important. It's just that we've had a very clear intent and that we structured the tree in a way that works for us. But nonetheless, I'm still going to go through it a bit. So at the far right, you have the base NPC Compound. Those are the compounds where the reusable subgraph. It's used by basically it is used by all human combat NPCs that we have in the game. As its top inputs, it has the critical events. Drew Reckoner mentioned them yesterday in the talk. They have run at a higher priority than normal combat, and they contain anything from direct orders to reactions to seeker mines and teammate reactions. After that, we have the normal combat. It mostly just connects to the right condition to the next layer. Below that, we have initial combat, and even though that logically, executes before normal combat, we just put it down into the side, just because. And then, as you can see here, the next layer is what we call the conditions layer. It's conditions. They pick the actions from the next layer, and it allows us to reuse a lot of common conditions instead of re-implementing them inside the actual critical events or the normal combat part of the behavior. The next layer is called actions. Well, it's what the NPCs do, and it also links up to shooting. And the shooting for this NPC, the shooting layer of the behavior handles all variations of shooting. It handles range, primary weapons, secondary, whether or not they're aggressive, and most of the things higher up in the tree link back here. As you can see, again, we allow for multiple parents to slim down the tree. Now, what you saw here is just the top level of the tree. Most of these things are actually compounds. So if we take a look at the critical events, for example, that then again mostly contains another layer of compounds. And we have this, it doesn't continue ad infinitum, but it does add up. I also wanted to show you a different behavior that we saw in the previous example, the seeker mine. It's a simple non-human. It doesn't have the compound that we saw before. Instead of just a simple priority list of things it wants to do. It also illustrates that if you actually use the font size and colors of the comment nodes, you can make it even more readable. And there's no additional information in the actual comment background colors. It just separates things. So that being done, let's continue. Now that we saw him have a dumb rider reaction to the seeker mine, let's prototype something more elite, more snipery. So in the top right of the tree, we're going to inject some new higher priority nodes and make him react. Instead of panicking, he's just going to shoot the mine. So up here in the top right, I'm first going to insert a new connection, get a dynamic selector node, and insert that. After that, I know I will have to react to a seeker mine, so I'll add an event reaction as a higher priority, and much in the similar way. And then after that, I need the information from the actual seeker mine, so I'll get the event source. I'll add it as a threat to the NPC so that he knows about it. After that is done, I'll need to actually shoot him. I'll introduce a sequence, and as the second part of the sequence, add threat being the first, I'll make him shoot. So let's just add the sequence, align things a little bit. As you do, zoom out, and then try to pick an appropriate shooting reaction. Yeah, aggressive shooting, that sounds perfectly fine. We'll just connect that to the bottom, save the behavior, and everything's ready to go. Now all we need to do is actually throw the seeker mine and hope that our a new part of the tree actually fires and everything is good. So at this point, we're expecting the top part to be blue and then him to shoot the seeker mine. And he dies. So something went wrong. Let's go back and have a look at that. What I'm going to do now is I'm going to scrub back and forth to see, okay, so the critical event parts, I'm just going back and then over them again. They light up blue. So the critical events, the thing in the bottom here is lighting up blue. We don't want that. We should be running ours. Okay, you have to actually have to specify that it's a seeker mine event that you're waiting for, not an invalid one. This wasn't exactly the bug I tried to show, but it happens, so I just went with it. So now that we've actually listened for a seeker mine, let's save that again, respawn the guy, and see if we get a different result. What we want, again, is for the top part to light up blue, for him to react and actually not die this time. So yeah, let's, once again, throw that little seeker mine. Seeker mine, go! Yes, so he killed the seeker mine, and we now have a sniper with spider senses. That's great. But what this hopefully illustrates is that we, by now, had the rapid iterations that we wanted. It's really easy to just quickly prototype with a couple of nodes. Save that and get the visual direct feedback even in the debugger. And as such, we sort of slowly managed to regain the confidence of our designers. They could build small things, test them out, instead of just diving deep into trees right at once. And that, even so, that I still don't think that would have been enough. Breaking old habits, it's pretty hard. So in addition to actually trying to fix all the workflow issues that we had, we also started sitting together. Sitting together, I mean, it changed everything, I think, because that allowed us to work really, really closely together and iterate on not only what we were doing, but also how we worked with it. We could sort of slowly change who was responsible for what, and with the graphs that we had, we could also sort of adapt the abstraction level of each layer to what the team actually needed. So now that we've sort of arrived there, who actually does what? Well, it's mostly power users, programmers and designers alike. They will create these compounds that we've been talking about out of highly specialized components glued together with flow nodes and simple math that can then be reused in the tree. And as a programmer, it is pretty important that you are familiar with how the trees work and how you want to work with them, because it's very often a lot better to create a collection of highly specialized nodes when working on a feature instead of one mega node that does exactly the thing you want right now. So then you can reuse those things later. Given that, we have a pretty high level of detail in the tree. Let's see. And you might remember this part from when I was looking at the behavior tree architecture. And now that you've seen, that is actually this guy. So that's one of the simpler human behaviors that we have. That was a bit of a shock. I spent some time actually just creating this new view of what it was actually doing. But that's not how we work with it. That would be completely impossible. The layers allow us to structure this, and it's also not 100% accurate representation of what's actually going on at runtime, because this is just the exploded view of what's going on in the editor. But still, it should give you an indication of just how much detail we have in our trees. And as such, if we had that would be completely unusable and spaghetti. That kind of nice looking, but not quite nice to work with. So one of the important things is to actually have reviews when you're working with this. It's very similar to code reviews, just with the nodes. And that goes both ways. As a coder, you might be able to sort of educate a designer on how to do things more optimally or similar and just get an understanding for what they're trying to do. But as a coder, when you're making changes to the tree, it's also really important that you're letting whoever is responsible for that behavior review it as well, so you're not breaking his stuff. That's quite important. And as I was talking about, since we do this easy editing, we also do easy errors. If you're not familiar with things, it's very easy to either give the wrong input or do some simple math errors. So for some of the, at least some of the major nodes, it's very important to sanitize your input. You don't want to accidentally do a cover evaluation for the entire Manhattan, for example, which has happened. So after this, I'm just going to move on to an easy example. Now, this is one of the bugs that we had, so I'm just going to read it. Like, the cleaner mechanic doesn't deploy the turret. We created a little vantage point for it and hope it would provide a focused turret gameplay section to beat the turret but sadly the NPC never places a turret. So we have an archetype, the cleaner mechanic, that actually spawns a mechanized unit on top of covers. And the reason I'm showing this, I'm just trying to show you how to set up for some real debugging and that you might need to combine multiple debug sources to do so. What I've done here is I've jumped into Manhattan. I've used console command to get me to exactly the right beat in the encounter that I want. I can use the same commands to just restart it if I want. But the first thing I'm going to do is I'm going to just scope the place, just see the lay of the land, see what I'm looking at. Okay, so we have a lot of NPCs. Now, if I just turned on lots of debug options, it would get messy pretty quickly. So I'm going to use one of our oldest filtering options for this type of situations. It's agents in debug mode only. So with this on, only agents that are actually in debug mode will generate debug information. So I'll select the mechanic, add the flag to him. This is actually on the entity in the code as well, which makes for a good start for contextual breakpoints in Visual Studio. And then I'll just run to the encounter, set things up. So what's going to happen here, I'm going to try to get the mechanic's attention, reproduce the bug, and as it turns out, I'm going to look at the behavior. I'm just trying to set things up here a bit. The problem is that we have a position evaluation that is successful. It turns green. He, as we might be able to see in the middle of the screen, he runs there, and then he runs off. So the reason for this is that, as it turns out, in the top level here that we're going to look at, the setup turret part, is that there is an additional test for the cover as part of the deployment. So we actually end up having two separate tests for the same thing that should agree, but don't quite. So I'm just checking the parameters. Like in this case, we're testing for 40 centimeter cover depth. I'm trying to figure out, okay, so this is returning much quicker than I expected. Going down to the actual deploy part of the behavior tree, it says it's fine, but it's over in a second, not showing any feedback, which is bad. Now I'll just jump in to the deploy turret part just to verify, just to see what's going on. And I can see, okay, it's 30 centimeters. The other one was 40. That should be fine. So I'll sort of move on from looking at the behaviors and see, okay, what was the actual position at this time? What cover positions are being shown for this deploy turret evaluation? So just kind of zoom in a bit to make it more clear. So we were looking for covers that were at least 40 centimeters deep. Now this little rail here is, I know that it's 15. So clearly something is wrong. I didn't have that information, so I'll just go grab that from my player. I kill off all the NPCs first, jump in with the player, and then just sort of recreate that debug information to get to know what the game, how deep the game thinks that one actually is. So I'll add the cover information debug, take cover. Yes, figure out that I'm not in debug mode on my agent, get the actual thing, and this one actually says it's 2.47 meters. It's lying. One step to the right, it's 15 centimeters. So you might see what's going on here, but I'll tell you anyway. So that cover evaluation is actually hitting one of the pipes on the tank that in the background. So, which gives the wrong result. So but why would that be such a big issue? Now, as I mentioned before, we had the other issue. We had two different tests. So the first evaluation says, okay, this is 2.47 meters. That's great. I'll go there. And as soon as you get there and try to deploy the turret, oh no, actually it's not. And then he just bails and runs away. And the reason for this is that this bug actually hides the real position that we want, which is the one in yellow on the right there. And so the behavior picks the wrong one and then fails. This was discovered relatively late, and we've also noticed that, okay, if we fix the cover depth generation issue, those two conditions match up, that's great, bug's gone. So we might get back to the inconsistent behavior, but for this, we just fixed the generation issue, and the bug was actually was done. So that was the best solution for us at the time. Now, in conclusion, I think one of the most important things is that you try to take responsibility for your own workflow, your own process. And in our case, like a lot of the tools that you saw actually comes from programmers working on behaviors, either debugging or adding things, and realizing, okay, this piece is missing. And then since we had the ability to just update our own tools, that's what we did. So then we could add small things over time to make it even better. Which brings me to my next point. You're never done. Like, you always constantly need to iterate on your tools, on your process, on what you're doing, and yeah. And what we're doing is we also want to do it together. Like, I truly believe that having a cross-disciplinary team not only makes things better, but I absolutely know that it's a lot of fun. Thank you. Yeah. So I also want to plug Nikolai Stefanov's talk on Friday on global illumination. It's there. If you have questions, we're going to be Philip Dunstan, Drew Reckner, and myself will be at the Ubisoft Lounge tomorrow at 11. Yeah.
What's the underlying editor for the node editor? Was that built into Visual Studio? Was that Visio? How much was off the shelf to get a node editor like that?
Oh, the node editor is, I mean, this is all part of Snowdrop. It's completely sort of homegrown.
For your data reviews for changes to that giant behavior tree, how do you visualize the differences, or do you?
I had a slide about that. I took it out. You probably want to invest, as we did, in a visual diff tool. So you can actually see when you did the first edit, those nodes would have, in the difference pane, would have showed up in green. So, okay, so you had these things added to your graph, and then you have other connections that are in blue, red things removed, and it's a lot better than diffing the text files.
Right, okay, so that's built into your engine. You weren't diffing the source files.
Yeah.
Same side. Go ahead, same side.
Great presentation, by the way.
Thank you.
When you went back in time to debug the behavior tree or the decisions that were made, at that point, that recording of going back in time, was that that only for the AI simulation, or was the world, like your whole, you're storing all this information? Just the debugging information.
Yeah, so it's just the debugging, all the debugging information that was available at that time. It does include, potentially scripts and other debug drawing, but it's not the actual world state. It is the debug state at that time.
Okay, so you had to instrument some of the debugging so that it shows up on the timeline for it to be there.
Yes, I mean the debug events or show up on the timeline, and then you can just view them. Yes.
Okay, well, thank you.
Okay.